Hey folks, Mike Johnson here. If it's got wheels and an engine, you're in the right place. On this channel, we dive into car repairs, maintenance tips, and everything you need to keep your ride running smooth. If you're into cars and want to keep learning, don't forget to hit that like button and subscribe. It really helps the channel out. All right, enough talking. Let's get into it.
The efficiency of an automotive engine relies on a subtle balance between various components, and ignition timing is one of the fundamental aspects of this complex process. In this article, we'll explore in detail what ignition timing is, its crucial role in engine operation, and how it influences a vehicle's overall performance. Fundamentals of ignition sequence. Ignition timing is a crucial component in the operating process of an internal combustion engine. Understanding its fundamentals enables us to grasp the essential role it plays in a vehicle's overall performance. What is ignition in an engine? Ignition in an internal combustion engine is the process that triggers the combustion of the air-fuel mixture in the combustion chamber. The aim is to release the energy stored in the fuel to generate the driving force needed to turn the engine. At the heart of this process is the spark plug, a small device located in the engine's combustion chamber. When the air-fuel mixture reaches a certain point of compression, the spark plug emits an electric spark. This spark ignites the mixture, initiating the combustion cycle. Key ignition components. Several components are involved in the ignition system to ensure precise, synchronized initiation of the combustion process. Essential elements include the spark plugs. These small metal parts are located in each engine cylinder. They generate the electrical spark needed to ignite the air-fuel mixture. Ignition coils. Ignition coils amplify the electrical current coming from the vehicle's battery. They transform this current into the high voltage required to create a spark powerful enough to ignite the mixture. Crankshaft position sensors. These detect the position of the crankshaft, the engine's rotating component. This information is crucial for synchronizing ignition with piston position, ensuring efficient combustion. By combining the action of these components, the ignition system ensures a timed sequence of events, enabling the engine to operate at optimum efficiency. The foundations of ignition sequence lie in the precise coordination of spark plugs, coils and crankshaft position sensors. Understanding these elements provides insight into how the engine converts fuel into motive energy, underlining the importance of a correct ignition sequence to ensure optimum performance. In the following sections, we will further explore the influence of ignition sequence on the combustion process and overall engine performance. Importance of ignition order. The ignition order in an internal combustion engine is of fundamental importance, directly influencing the combustion of the air-fuel mixture and, by extension, overall vehicle performance. In this section, we take a close look at the relationship between ignition timing and combustion, and the consequences of incorrect timing. Relationship between ignition order and combustion. The efficiency of the combustion process depends largely on the precise timing of ignition in each engine cylinder. The ignition sequence determines when each spark plug is activated, which in turn influences how the air-fuel mixture is ignited. Correct ignition timing ensures a logical, orderly combustion sequence. Each cylinder ignites at just the right moment, maximizing pressure in the combustion chamber and producing an even driving force. The result is constant engine power and optimized fuel consumption. Consequences of an incorrect order. Incorrect ignition timing can lead to a series of problems affecting engine performance and vehicle fuel efficiency. A loss of power. An out-of-sync ignition sequence can lead to a loss of engine power. Some cylinders may be less active than others, compromising overall vehicle performance. Increased fuel consumption. Inefficient combustion resulting from an incorrect firing order can lead to increased fuel consumption. Poorly synchronized cylinders waste energy and require more fuel to maintain performance. Harmful emissions. Incomplete combustion generally produces harmful emissions. Inappropriate ignition timing can increase emissions of atmospheric pollutants, contributing to environmental pollution. Premature engine wear. Uneven stresses on engine components due to incorrect ignition timing can lead to premature wear of parts, reducing engine durability. In short, the importance of ignition timing lies in its ability to directly influence engine combustion, thus impacting power, fuel consumption and vehicle emissions. By dictating the timing of combustion, ignition timing plays a crucial role in engine performance and fuel efficiency. A correct ignition sequence allows the engine to run smoothly, while an incorrect sequence can have adverse consequences for power, fuel consumption and the environment. In the following sections, we explore the different ignition sequence methods and their influence on the engine. Common ignition order methods. Ignition order in an internal combustion engine can be established in a number of different ways, each with its own advantages and disadvantages. In this section, we'll explore three common methods of ignition order: inline, star and cylinder specific. Inline ignition order. In this configuration, the spark plugs are activated in a linear sequence, generally following the order of the engine's cylinders. This method offers simplicity of implementation and ease of maintenance. It is often used in multi-cylinder inline engines. The main advantage of the inline ignition sequence lies in its simplicity of design, facilitating series production and maintenance. However, this method can have disadvantages in terms of engine balancing, particularly in engines with a large number of cylinders. Star firing order. Some engines use a star-shaped ignition sequence. In this case, the spark plugs are activated in a star pattern, creating a sequence that distributes combustion evenly throughout the engine. The star firing sequence is designed to improve engine balance, reducing vibration, and ensuring more uniform combustion. This can lead to smoother performance, particularly in multi-cylinder engines. Cylinder-specific ignition sequence. With the advent of electronic engine management systems, some modern vehicles adopt a cylinder-specific ignition sequence. This individualized approach enables more precise control of combustion in each cylinder, optimizing engine performance. The specific ignition sequence for each cylinder enables the ignition sequence to be dynamically adjusted according to driving conditions. This helps maximize fuel efficiency and meet varying engine power requirements. The different ignition sequence methods offer a variety of approaches to optimizing combustion in an engine. Whether inline order for simplicity, star order for balance, or cylinder-specific order for dynamic adjustment, the choice depends on the specific needs of the engine and the performance required. In the following section, we'll look at setting the ignition order, an essential aspect in adapting the engine to varying conditions. Setting the ignition sequence. Adjusting the ignition sequence is essential for optimizing engine performance and ensuring efficient operation. In this section, we explore the adjustable parameters, tuning methods, and diagnostic tools used by mechanics to ensure precise ignition timing. Adjustable parameters. Modern vehicles are equipped with electronic engine management systems that allow various parameters to be adjusted, including ignition timing. Among the adjustable parameters is ignition timing, which determines the precise moment at which each spark plug is activated. Mechanics can adjust ignition timing to optimize engine performance according to driving conditions. A more advanced setting can be used to boost power in specific situations, while a more retarded setting can be chosen to improve fuel efficiency. Diagnostic tools. Setting the ignition sequence requires the use of advanced diagnostic tools. Electronic scanners give mechanics access to engine management system data, including ignition parameters. These tools provide real-time information on engine performance, enabling precise adjustment of ignition timing. Modern diagnostic tools also offer advanced features such as fault code detection, crankshaft position sensor monitoring, and the ability to make real-time adjustments during road tests. Manual setting. In some cases, the ignition sequence can be set manually. This may involve direct mechanical adjustments to the ignition distributor, or modifications to electronic parameters using an onboard computer. Manual adjustment requires a thorough understanding of engine operation and manufacturer specifications. Qualified mechanics can use this approach to fine-tune the ignition sequence to the vehicle's specific needs. Adjusting the ignition sequence is a crucial step in maximizing engine performance. Thanks to adjustable parameters, advanced diagnostic tools and manual tuning, mechanics can tailor the ignition sequence to specific engine requirements and driving conditions. In the next section, we'll explore the technological evolution of ignition timing and its impact on modern vehicles. Technological evolution of the ignition sequence. Ignition timing has undergone a significant evolution with advances in automotive technology. Modern systems incorporate sophisticated technologies to optimize engine ignition, improving efficiency, performance, and durability. In this section, we examine two facets of this evolution: electronic ignition systems and programmable ignition systems. Electronic ignition systems. Early internal combustion engines used mechanical distributors to regulate ignition. However, with the advent of electronic technologies, electronic ignition systems have become the norm. These electronic systems offer more precise control over the ignition sequence. In an electronic ignition system, a crankshaft position sensor transmits real-time data to an electronic control module, ECM. The ECM uses this information to determine the optimum moment to trigger ignition. This precision makes it possible to dynamically adjust the ignition timing according to various parameters such as engine load, rotational speed, and engine temperature. The technological evolution of ignition timing has dramatically improved the way internal combustion engines work. From electronic ignition systems offering greater precision to programmable ignition systems enabling in-depth customization, these technological advances have contributed to optimum engine performance, improved fuel economy, and reduced pollutant emissions. In the general conclusion to this article, we will summarize the key elements discussed and emphasize the continuing importance of mastering ignition timing to ensure optimum automotive performance. Frequently asked questions: why is ignition timing important to engine performance? Ignition sequence has a direct impact on combustion, engine power, fuel consumption, and emissions. The correct sequence is essential for optimum engine performance. How can the ignition sequence be adjusted? Adjustment of the ignition sequence can be achieved using adjustable parameters in the engine's electronic management systems. Mechanics can also use advanced diagnostic tools and manual adjustments to optimize ignition timing. How has ignition timing evolved technologically over time? In conclusion, understanding engine ignition is crucial for anyone looking to enhance automotive performance. From the spark plug's role in initiating combustion to the intricate timing required for optimal efficiency, every aspect of ignition contributes to the overall power and responsiveness of a vehicle. By grasping these concepts, you can make informed decisions about maintenance and upgrades, ultimately leading to a more powerful and efficient driving experience. Thank you for watching, and we hope this insight into engine ignition helps you on your journey to automotive mastery.